It's that time of year again where I'm feeling a little cocky. Shop cocky, that is. You know, that surge of confidence that you can make anything. I've gotten to know these machines pretty well over the last 2 years, and I'm itching to put myself to the test with a complicated project. And I mean really complicated. This is a steering knuckle for a Formula race car. I know, pretty intense. Almost looks like it was specifically designed with CNC in mind. So it would be bananas to try and attempt this on a manual machine, right? But what if we up the stakes a little bit? Considering these parts are for a race car, it seems fitting I should make this a race myself. So we're going to be racing an actual CNC machine, and not a cheap one either. So let's see if these old machines can keep up, or if I'll be left holding my parts. Okay, why am I making parts for race cars? Well, like last year, I'm helping out the University of Kentucky Formula SAE team. They go by Formula Kentucky, and they design, build, and compete in a Formula-style race car every season entirely from sponsor donations and support. Most of the work is done by the students, but they still need some help on the more complicated bits. And that's where we come in. This year's car needs 4 of these uprights. They basically go in here and hold the wheel to the suspension. There are 2 of one design and 2 of a mirrored version. I'll be tackling these 2 here in my shop on my 30-year-old manual machines. And my competition? A $600,000 DMG Mori DMU75 monoblock 5-axis CNC milling machine with a 20,000 RPM liquid-cooled spindle, 60-position tool magazine, and an integrated coolant temperature conditioning system. That's a mouthful. And I'd be lying if I didn't say I was a little intimidated. But how did I manage to get access to this? Well, you might remember my friend Craig from previous videos. Other than being a test dummy for puzzle builds and a donator of lathes and tooling, he also runs a high-precision CNC machine shop here in Kentucky called Machine Time. They pride themselves on being the shop that takes the orders nobody else can make. Because machining crazy parts and machining crazy parts to super tight tolerances are 2 very different animals. And Machine Time tames the latter, so these uprights should be no problem. Now I wanted to do a sort of ready, set, go for this race, but when I showed up, Craig was already elbow deep in the first part. And not on the machine I thought I was racing. Apparently he's already been at it for 2 days. But considering he's here on a weekend and donating the material for my half of the build as well, I'll let it slide. You better believe I'm still counting those days though. Now Craig's machines are fast, but they won't do anything without a program. And that's what he's been working on. Using CAM software to build up what are called tool paths, which are like little nuggets of the full program. Roughing one side, cutting a fillet, milling a bore, are each tool paths. And this first part is just a proofing part where Craig runs through each of the tool paths one at a time to make sure there are no oversights that could crash the machine. Okay, this is a race after all, so let's get back to my shop and get started. The Formula team provided a drawing, but it only has the major dimensions and tolerances. Obviously, they expected this to be made on a CNC, so the rest of the info is in the 3D model. Just like Craig is building up his tool paths, I'll need some tool paths of my own. And that's basically what each of these sheets are. Yep, there are a lot of them, but they'll all make sense in time. I already mentioned that Craig generously provided the material for my parts as well, but it looks like he was a little too generous. No sense in turning all this extra meat into chips. You know, I bet this was his plan all along. Burning up time before I even get started. I'm not counting that, Craig. Okay, let's get this block squared up. And we're just small enough for my big Mamma Jamma fly cutter. Never gets old. I could continue to square this up here in the vise, but this is a race, so we're going to take all the shortcuts we can. This part is basically going to live on this rotary table from here out, so might as well do the rest of the squaring here as well. The clamps obviously prevent me from using my preferred implement here, but I get to make up for it with this nice long end mill. This squaring may seem like a waste of time, but it's going to help me immensely on some future setups. It's simple things like this that you start to pick up on the more projects you do. That's a big reason why I love machining. I'm always figuring out new and better ways of doing things. And it's the best because it's so hands-on. Heck, it's the reason I joined the Formula Kentucky team myself back in college. But you don't have to have a machine shop or even join a race team to learn hands-on. And that's why I'm excited about our returning sponsor, Brilliant. Brilliant's online platform makes learning math, data science, and computer science both easy, effective, and fun. By taking complex subjects and breaking them down into bite-sized, digestible lessons, you don't have to work so hard, nor do you have to cram your schedule with another time-consuming commitment. Brilliant was made with busy people in mind, so the lessons only take 15 minutes or less a day. But what I like the most is that every lesson is interactive. This means that your brain is engaging in active learning, which makes knowledge retention 6 times more effective than sitting through a lecture or a video. Plus, it's a whole lot more fun, too. But you don't have to worry about getting in over your head because Brilliant actually builds a learning path specific to you. Just answer a few questions when you get started, and you're off to the races. Brilliant is more than just learning. It helps you reach your goals. So whether you're trying to level up your problem-solving game and become the go-to person at work, trying to get that unfortunate C up to a shining A, or just impress your loving wife with your enormous brain, Brilliant can help you get there. Try it yourself free for 30 days by visiting brilliant.org/inheritance. And when you decide it's for you, the first 200 subscribers will get 20% off of Brilliant's annual premium subscription. Thank you, Brilliant. Okay, time to Swiss it up. Sorry, my jokes are a little cheesy. This circle of holes is for the bore, and the rest are basically all corners on the part. We'll get to those soon, but first I want to turn all these small holes into a big one. Like my grandfather always said, waste not, want not. This bore is for the spindle bearings, and it needs to be a precise diameter. The normal approach for a large bore like this would be to use the aptly named boring head. But no sense in wasting precious time setting all that up when this end mill can do the job just as well. Actually, it's a little better for this. When I get to really dialing in the diameter the last few thousandths, instead of feeding the table along the bore radius, I can instead feed it along the tangent axis. This basically acts like a superfine feed for getting the bore within a 10,000th of the spec. Let's see what Craig's up to. Seems things are a little boring over here as well, though the way he dials his in is pretty slick. Rather than fumbling around with snap gauges, he can just swap to a touch probe that communicates wirelessly to the controller and spits out the exact diameter. It's basically like its own CMM machine. So all Craig has to do is run the toolpath again with the necessary offset to get it right on the money. Okay, enough showing off. Back at my mill, we can start working on the perimeter. And this is where the rotary table can really shine. Running at the first angle to 0, sweeping to the second angle, then continuing out the other side. This side has a tie rod flange Clevis type deal, so I can shape this out as well. But it's a little hard to see from this angle. Turn it around! Oh, I can just turn this around. Now I left just the slightest amount of extra material on this face for a finishing pass. So I'll take the final cut that should smooth everything out. Well, almost anyway. Without being able to feed on a dime, the tool's bound to rub a bit. This unsightly lump of material here was saved for the ball end mill to take care of, but not in its current state. The flutes aren't quite long enough to reach, and I'd rather the shank not be rubbing on my finished surface. So, time for the first side project. That ought to clear. Let's cut that fillet. Last on this side is the actual clevis. But this radius is at a really odd dimension of 0.363 inches. No chance I have an end mill that size. I could probably fudge the dimensions and use something close because this isn't an important feature, but might as well do it right. Even if it might be kind of boring. With that to size, I can finish out the clevis with the end mill. Let's check in on the competition. Man, still working on that proof part. I guess he really wants to make sure everything is right. I can't blame him though. If something's going to go wrong, better it be on the less expensive machine. But on my even less expensive equipment, we're ready to cut side number 2, which is more the same, so just enjoy the chips. Something I could mention here is that I'm always feeding in the direction that the cutting forces flex the end mill away from the finished surface. This is the same principle as climb milling, but since this is a slotting operation, it's not technically the same. After all, climb milling is bad, and I would never, ever, ever, ever do that. You see, the problem with climb milling on lead-screwed machines like this is that lead screws have backlash, which is like a little window of free play. And when you climb mill, the cutter wants to pull the work along. Take a deep enough cut, and that end mill can pull the work into that free play window faster than it can keep up, and it will break. This is the preferred method of machining on CNC because the cutter is pushing away from the material, which helps preserve part dimensions. And CNCs can get away with this because they run on ball screws, which have effectively zero backlash. But on my machine, as long as I don't get too deep, I'm in the clear. You can actually get a pretty good feel for this because the hand wheel gets lighter. But don't take my word for it. Remember, I'm just a guy pretending to be a CNC machine. Okay, now for the thing you're all probably wondering how I'm going to do. The weight reducing pockets. Well, surprise, surprise, it's the same as everything else. Just rotating the table to the required angle and milling them out one side at a time. That's actually what a large chunk of these drawings are. Just updated start and stop coordinates with the rotary table set at the different angles. Ha, who needs CNC? Speaking of, how are the computer nerds doing? Well, finally finished that dang test part. I will say though, Craig's work holding technique here is pretty slick. Clamping off to the side made it easy to reach all the angles of the part with one single setup, leaving the final operation of milling down to a thin web that he can just bend off. With that part complete, that means the program is sorted and now the pressure is on. Let's get back to work. I've got my flanges to size here, so I'll drop the corresponding holes in them, and now we can work on the last cut of this setup, the large radius on this flange. I genuinely hope this isn't getting too boring. The trick here is getting the boring head set to the right diameter before starting to cut. An easy way to do this is to take a known edge of the part, like here, and offset the head the needed radius from that edge. Then adjust the cutter until it just touches that face and the diameter is set. Something about using a boring head like this always feels like a sin. But the results speak for themselves, so it must not be all that bad. With that finished and quadruple checking I've done everything I can from this angle, we can finally break down this setup. Meanwhile, back at machine time, Craig is setting up for his first official part. He did another smart and cut away most of the unneeded material on the bandsaw, which should save him some time on the milling. All he has to do now is prepare the clamping area. Good thing the CNC can help with this as well. Certainly wouldn't want to waste time doing something so complicated on a manual mill. With that ready to go, we are ready to go to the big boy machine, the $600,000 Mori, which I just found out Craig isn't proficient with. So he convinced Mr. Colton here to come in on his day off to help out. Back over at IM, we're ready to start working on the slanted faces on the top and bottom. This is actually the reason I took time to square everything up early on. Square sides are a vice's best friend. This first slant terminates in this corner, and I can eyeball this transition, but I really don't want it to look like doo-doo. So a quick swap to an edge finder helps me find the center of that corner, and I can just offset the mill accordingly. The other slant is a similar story. While I'm here, I also want to knock out the 1/4 inch radius on this edge, which calls for another, you guessed it. I know you're getting really excited wondering why I'm making lathe tooling, but calm down. It's a lot more boring than that. Yet another inappropriate use of the boring head that works out perfectly. Back at machine time, Craig fills Colton in on, well, I don't know what. They were talking in hushed tones, so they're either devising ways to sabotage me, or just talking about things to watch out for in the program. Whatever the case, Colton spent some time getting familiar with the part, and then got the tools he'll need mounted in the machine. If there's a difference between the tooling specified in the cam and the actual tooling dimensions, this machine will actually compensate for all that using this fancy laser measurement system. Looking at this drill though reminds me I have my own holes to drill. There are 2 from the top that go here and here, so might as well get this hunk out of the way on the bandsaw. I can use all those square edges from before as references so I don't have to worry about trying to locate on the center bore. Then it's just a matter of drilling the 2 holes. But, of course, it's not that simple. This is as low as my table goes and as high as the spindle raises, and that's not going to work out. I've got a solution though, and it involves another quick trip to the surface grinder. Ah, so spacious. With those two knocked out, I can carve the next corner off here. Then get this set up at an angle for a couple of threaded holes in the side. Back at the Mori, the program is finally getting started. And even though it took a while to get here, this isn't going to be like the test part. With the program proofed, they're no longer going toolpath by toolpath. This is just going to run straight through. So now the clock is really ticking. We're not too far off back at home base though. I went ahead and removed the last two corners on the bandsaw, but this bottom inch of material is going to need another method. Seems like a good excuse to push that big old fly cutter to its limits. Hold up, I need to see that again. It shuts off my brain. Okay, with my senses coming back to me, I'll switch back to the end mill and hollow out the pocket on this side. Then finish out the corners like all the rest. Meanwhile, the Mori is moving at an absolutely blistering pace. Hard to see because of the monsoon of coolant, but it's already hollowing out the triangular pockets. Easy work when you don't have to use a rotary table to set all the angles. And after a lightning quick tool change, the machine's now drilling holes, which it can do all at once just by rotating its extra axes. Back at my mill, I'll still need my own fourth axis for some of the last operations. I'll need a way to both center and angle the part though. I could probably manage this with some indicators, but I've been itching to use the lathe all project. Okay, with this plug I can easily center the part on the rotary table, leaving just 1 degree of freedom to consider, which is easily trammed with the indicator. I'll go ahead and cut the bearing bore needed on this side, then finish out the flange. We're getting really close now. As is the Mori. It's basically got all the roughing complete by this point, but there's been a slight change of plans. Mr. Colton had to head out, so Craig's stepping in to finish. And that means getting set up back on the machine he knows best. Luckily, Craig is a genius and has both machines set up with the same vise hardware, so it's just a matter of moving it over to the Haas. Craig is even more persnickety about precision than I am though, so he's double checking the alignment on the bore with the indicator. Which of course was bang on. So Craig set the machine on its way with the finishing passes. But I'm even closer to the finish line. I just have 4 simple corner rounds to take care of. So I'm going to use my favorite tool of all, the radius fixture. The only downside for me is every one of these corners requires a different setup and a little bit more time. This is getting really tight, and Craig is right on my tail. 1 down. Oh no, he's hogging out the brake flange. That's 2 down. Come on, come on. Profiling the flange. 3, and we're so close. He's almost through. Last one. Ah, dramatic ending. Maybe that was a bit too dramatic. Pretty amazing though that after all that, it came down to a photo finish. I mean, what are the chances? It's not like I could have edited the video like that or anything. Okay, you got me. I may have skewed things a bit to build the excitement. So, who won? Well, Craig was honest right off the bat and said that he spent 2 days working on just the program, so about 12 hours. I, on the other hand, created the few additional drawings I needed and came up with my plan in only 2. Craig needed 2 hours to prepare stock, tooling, and work holding, and another 6 hours to proof the part, carefully verifying each toolpath. where I was making chips on the actual part after about 30 minutes on the bandsaw, which you'll remember I'm not counting. Then finally, the cycle time on the Mori for the first part was 3 hours, and my cycle time? 23. Cut out a couple hours of futzing with the camera and we're exactly the same? Seriously? I didn't even think I stood a chance. I just thought this would be a cool video concept. It never occurred to me how much time goes into just preparing a CNC program. But it makes sense now that I've seen the process. When you aren't physically involved in every cut of the part, you have to make absolutely sure the machine isn't going to do something malicious when you aren't looking. Now, there is one minor detail I'm leaving out. We each still have to make our second part. And this is where things start to crumble. With my process refined and tooling made, I could probably knock out number 2 in 18 hours. And Craig is just another 3, as would be every part after that. This is why CNC is so powerful. Once the initial time investment in the programming is done, the parts literally start falling out of the machines. And this isn't even an optimized program, which Craig estimated they could get down to about an hour per part if they really tried. Everything you saw Craig and Colton do was done in one day, while all my efforts to this point were 4 days of work. So yeah, they get busy at machine time. And manual machining just can't keep up with that. But for onesie-twosies, it can still shine. Which, I have to be honest, makes what I'm doing here with this channel feel a lot more relevant. I'm not just a guy playing around in a shop with outdated machine tools. Now I've got a few more days of work ahead of me, but before I go, I want to thank Formula Kentucky for letting us be a part of this year's build. And I want to extend an even bigger thank you to Craig and Colton. All in, this was about a $6,000 donation from machine time and material and time. And being a Formula Kentucky alumni myself, I know what a huge difference this makes for the team and making it the competition. So thank you, you guys. And to everyone else, thanks for watching, and see you next time. Just one more thing, because I know people are going to ask. How much did that final part weigh? Well, the original billet and the final part talk about some serious material removal. At least I did my best to keep as much of it whole as I could. Now, actually, thanks for watching, and see you next time.